So naming of mononuclear coordination compounds. Can someone say what is this mononuclear coordination compounds? See, I told you in the previous class, what is this mononuclear? It's a coordination compound where it containing only one single metal atom. You can say it contains only single metal atom, or you can say single central metal atom. It could be atom or it could be ion. And this single central metal atom or ion, it is surrounded by the ligand. So surrounded by ligand. So those are called as mononuclear coordination compounds. Sometimes the coordination compounds can contain more than one central metal atom, or they contains the single central metal atom. If it is single central metal atom, it is called as mononuclear coordination compounds. So let's see how you will give the IUPAC naming for these mononuclear coordination compounds. Okay, so in this, the cation is named first in both positively and negatively charged coordination entities. Okay, so what does that mean? So when you are naming a coordination compound, first you need to identify the cation. Okay, so remember, when you are giving the name for these coordination compounds, first thing that you need to do is first identify the cation. Identify this cation and name it. Okay, so the cation is named first and name it. So identify which one is the cation and name it. Then you will be giving the names for the other components. Okay, so remember this. First, we'll be giving the name for the cation, then name the remaining components. Okay, so this thing will do when this coordination entity is containing both the positive and negative charge. Remember this. Okay, you are taking. I told you yesterday what is meaning of coordination entity. So when you have this coordination entity, in that if you are having both the positively and negatively charged components, first we'll be giving the name for the cations and then we'll be giving the name for the other components. Other components in the sense the anions and the neutral compounds. So remember this. So this thing you will be doing it when you have coordination entity containing positively and negatively charged. Okay. Is this clear?
Yes.
Yes, sir.
So the first rule. Second rule is the ligands are labeled in an alphabetical order. Okay. So first you will be giving the names for these ligands in an alphabetical order. Remember this. So ligand naming order that you will be doing based on the alphabetical order. So named in alphabetical order. And this ligand names comes before the central atom or central ion. Remember this. So it comes before the central atom or ion. Remember this. So you will be giving the ligands names first. In that ligands names, you will arrange them based on the alphabetical order. Then you will be giving the central atom or central ion name. And if in case you are having these multiple prefixes, so whenever you are having these multiple prefixes, you don't need to consider their alphabetical order. Okay. First, suppose if you are having multiple prefixes like di, tri, tetra. Okay. So these are not considered for determining the alphabetical order. For suppose if you have any ligand that is having di ligand, tri ligand. So we should not consider these as the first alphabetical word. Okay. And determine this will come first because the D is first compared to T. Remember this. So these are not considered when determining the alphabetic order. Is this clear? Is this clear?
Sir.
Yes. Yes, sir.
You can take an example like this. For suppose if you have a chloro, if you have a amine, a ligand, and you have a chloro ligand, so which one will be choosing first?
Amine.
Which one? Huh?
Amine.
Amine will be choosing the first and then chloro. For suppose if you are having triamine and dichloro, which one will be choosing first?
Amine.
Yeah, we'll be choosing still this one as the first. We will not consider D or T in this case. Okay, so that's what this means. So whenever you are having this multiplicative prefixes, these are not considered for determining the alphabetical order of the ligand. Okay, is this clear?
Yes, sir.
Yeah. So next one. So ligands based on their charge. So you can be having the anionic ligands, that means the negative ligands, or the neutral ligands, or the positive ligands. Okay. So how we will be giving the name for all these. First, suppose if you are having the anionic ligands that ends with the word O. Okay. So then you will be giving. So see here. For suppose you are having the uh, like nitrate. So the ending you will be giving with a O. So remember, it should be end with a O. So NO3 minus, nitrato, CO3 2 minus, carbonate. It should be changed to carbonato. MeCO2, that is methyl CO2. That's we can call it as aceto. Okay, or ethanoate. It should be ethanoate, that is changed to ethanoato. Understood? Ethanoate. The E has changed with O. Ethanoato. Understood? Acetate has changed to O. Remember this. Is this clear? You should know this. You should remember this. These are few things, the common, very regularly repeated ones. So I'm giving you, just remember this. Write down these lists somewhere. So ACAC, that is acetyl acetonato. SO42 minus, that's sulfate sulfato. Thiosulfate thiosulfato. Cyanato. Just remember for anionic, the end should be O. Remember this. It should end with O. Is that clear? If in case the ligand name ends with ITE within the anionic, then it should change it to ITO. So E is changed to O. So sulfite, sulfito, chlorite, chlorito, hypochlorite, hypochlorito, nitrite, nitrito, hydrogen sulfito, hydrogen sulfite as changed to sulfito. Is that clear? So this is sulfite, this is chlorite, this is hypochlorite, this is nitrite, this is hydrogen sulfide. So all these has changed E with O. So the E has to change with O. Or you can say the ITE has to change with ITO. Is that clear? You can also see ITE has changed to ITO. So fluoride, chloride, bromide, iodide, which has changed to fluorido, chlorido, bromido, iodido. Here also the cyanide, cyanido, isocyanide, hydride, hydroxide, deuteride, amide, imide. So all these has changed with the O. So remember this. Here you should be careful. First, suppose the NH minus 2. If it is minus 2, then we call it as imido. Don't confuse, they both look same. If it is NH2 minus, then it is amido. Understood? If it is NH2 minus, then you call it as amido. If it is NH minus 2, you call it as amido. Is it clear? If it is N3 minus, you call it as nitrido. You remove all the hydrogens, it will become nitrido. So NH, NH2, N minus 3. So next one you can see here. Yeah, nitrido, N3 minus. And see here, you should not confuse here. This is N3 minus, whereas here it is 3 minus. Here only single minus. Remember this. Here there are 3 nitrogens. Here only single nitrogen with the minus 3 charge, which is nitrido. Here 3 amines with a single negative charge, azido. Okay, the same here. O2 minus oxido, O2 2 minus peroxido, O2 minus, it is a superoxido. S2 minus, we call it as thio. HS minus, we called it as mercapto. Don't confuse here. They both almost looks like the same, but you should not confuse here. Remember that. Is this clear? Up to here? Any doubts?
Yes, sir. No, sir.
Okay, only Mandara and Sharon responded. What about the others?
Yes, sir.
Yes, sir.
Here also, you see. So tell me, what is ambidendant ligand? I think we have discussed in the last class. What is meaning of ambidendant ligand?
Ligand has two different donor atoms.
Yes. So you can say the ambidendant ligand, it means it's a kind of ligand where the central metal atom or central ion, okay, so they will bond with a different donor atoms, okay, but only one at a time. So remember, type of ligand where it can bond central metal atom, or you can say the ion through different donor atoms, but only one at a time. Remember this. So these groups, usually they contain multiple binding sites. Okay. So they will be having multiple potential binding sites. You can see the example here. For suppose Cn minus and Nc minus. Okay. So C triple bond N, here carbon is binding, or N triple bond C, where here. So in one case, the binding is happening through the carbon. In the other case, the binding is happening through the nitrogen. Remember here. So if it's binding happening through the carbon or binding happening through the nitrogen, so you should know. But only one will happen at a time. That's one thing. Second one is they are having multiple potential binding sites. For suppose the carbon one and the nitrogen one. Both are same compounds, but they have a two binding sites. Understood? Here, you can see NO2. You can write this way, or you can also write ONO. That's also one way. ONO minus. You can see here more examples. Cynato, cynato O. As the binding is happening through the oxygen. If the binding is happening through nitrogen, isocyanato, cynato. If it's happening through the S, thiocynato, thiocynato S. One second, guys. Yeah. Is that clear?
Yes. Yes, sir.
Yeah. Next one. So for neutral ligands, we will not be giving any specific endings. For suppose water, we are not giving any specific ending. Simply we'll say aqua, amine, carbonyl, nitrosyl, acetamide. We are not changing the ends. You can see here, methanamine, methyl phosphine, benzene, methyl isocyanide, triphenyl phosphine, pyridine. You should know all these. When you are naming, you should know all these things. For suppose C6H5N, what should you give pyridine? PPS3, triphenyl phosphine, CS3NC, methyl isocyanate, benzene. So you should know it. Next one. So here CNNC. NO2, ONO, nitro, that's binding happening through the oxygen, so it is indicate dash O. If it is happening through nitrogen, dash N. If it's happening through N, happening through C. See, here both are same compounds. C triple bond N. So that's why you are writing in different way. So it is called as iso. Iso means the same component, but in different way you are writing. I mean, different, the bond is happening through different ways. So we are mentioning here the iso. Remember that. So when do we use the example iso is? Remember this. So just know this. So when we will be using this iso word, so this is usually used to distinguish between two different modes. Two different bonding modes. So which mode are you making? Is it CN? You are making the bond with the nitrogen, or you are making the bond with the carbon? So which mode are you using for bonding? For that, you will be representing the word iso. Okay, they are same ligands, but they have a different mode of bonding. So same ligand, but different mode of bonding. So we will be using the word iso for that. Remember this. Is that clear? So you can say C triple bond N. The binding is happening through the carbon. C triple bond N. The binding is happening through the nitrogen. Both are same components, but one is, they are different modes. Even you can see here, the SCN, where the bond happening through the nitrogen atom, or you can say MNCS. One is this way, the other one is MSCN. So remember, here you can see here there are two ways are there for SCN. One, the central metal atom is attached to the nitrogen, or the central metal atom is attached to the sulfur. So in this case, the bond is happening through the nitrogen atom. In this case, the bond is happening through the sulfur atom. So remember this. So here bonding is happening through nitrogen atom. In this case, the bonding is happening through sulfur atom. Remember this. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
So next one, you can also use this thiocyanato Ks or thiocyanato Kn. So you will be using the thiocyanato Ks. That's when the bonding is happening through sulfur. Thiocyanato Kn. So this you will be using when the bonding is happening through nitrogen. Remember this. Thio means what? The sulfur containing compound. Remember this. Whenever you see the word thio, thio means sulfur containing atom. Is that clear?
Yes.
Yeah. So that's how you will be giving the naming of ligands with a neutral ligands. So we'll see more. Actually, these slides are repeated again. Just I'm going forward. So next one, the naming given for the cationic ligands. Remember, whenever you see the cationic, it ends with IUM. For anionic, it ends with O. For cationic, it ends with IUM. For suppose you can see here, nitrosonium, hydrazonium, nitronium. Remember this. If it is an anionic, it always ends with IUM. If it is a anionic, sorry, it ends with O. If it is a cationic, it ends with IUM. So if a number of same ligands are present, then prefix is used. Remember this. And remember, when you are writing this coordination sphere, remember all the ligands are listed in the alphabetical order. For suppose you will be seeing here. So first of all, same ligands, when they are present in more, you will be using the prefixes like di, tri, tetra, penta, hexa, hepta. For suppose you can see here, there's no deletion of the vowels or use of a hyphen. For suppose we will not be writing any vowels here between, there's no deletion here. So we'll be simply writing tetra mi. I'm not simply putting together both the A's as single A. So I'm not deleting any A here. So no deletion of the vowels or use of hyphen to differentiate this tetra with mi. So there's no hyphen is used here. Or there is no deletion of both the A's. I kept both the A's together. And I am not given any space also. Any punctuations are also not given. So remember this. So tetra mi. That's it. You will be writing like this. So double A will come here. Is that clear? First, suppose if it is with the water, you will be simply writing it as aqua mi. So here, I'm not deleting the word double A here. I'm simply putting together both the A's. Next one. For anionic complexes, the names of metal ends with 8. Replace IUM, UM or ENUM for metals. For suppose you can see the example here. So aluminium, which is IUM, replaced with ATE. Platinum replaced with ATE. Molybdenum replaced with molybdate. Zinc replaced with 8. So remember this. Is that clear?
Yes.
Yes, sir.
Yes, sir.
So generally, usually they will end with the word IUM, but if the word itself is containing IUM, then you will be replacing with ATE. Remember this. Okay. Next one. So nickel, nickelate, cobalt, cobaltate, iron, ferrite, manganese, manganate. So all these are anionic complexes. Okay, that is metal ends. Remember this, these are all metals. For metals, you will be following this order. For cationic and neutral complexes, the metal named as the element. Okay, this is only followed for the anionic. Okay, see here. For anionic complexes only, you will be writing this ATE. But if it is a cationic or neutral complexes, which is also metal, that means you will be using simply the element name. You will not be changing into any other words. Is that clear? And next one, we need to find out the oxidation state as well. And based on the oxidation state, you will be putting them in the brackets and you will be giving in the Roman number. So see here, if the oxidation state is -1 for the net compound, you will be putting minus Roman number 1. If it is +2, you will be putting within the brackets the Roman number 2. Remember this. So if there is a water of crystallization, it is to be included in the name as well. Okay. So remember this. For suppose here the water is present here. Okay. Within the entity, within the coordination entity, then you will be including the water name as well by giving the aqua. Understood? So see here, tetra aqua dichloro chromium 3 chloride dihydride. This is the entire compound name. And no space is left between the names that refer to the same coordination entity. Remember this as well. For suppose you can see here. let's try to give the name for this. So first of all, we need to find out the oxidation state, and we'll be writing this in the alphabetical order. So how do we calculate the oxidation state? We have data in the previous class. So what is the central atom here? Central metal atom.
Chromium.
So chromium is the central metal atom, which you will be giving X. And this one, NH3 thrice.
It's neutral. 0.
So 3 into 0. And here,
Water also neutral.
so 0. And chlorine, which is a present outside. So which will be having the opposite charge for this. And what is the charge for the chlorine?
Minus.
-1, which is equals to 0. So X minus 3 is equals to 0. X is equals to 3. So what is the oxidation state for the central atom? 3. Okay, so remember this.
Sir, I
So
was
you
one
will,
that.
yes,
Sir, chlorine is coming after the square bracket, right? So then that 3 should be written after the equal to, right? After.
okay, I'll be writing that order. First, suppose you will be putting here -3. Okay, but what will be the charge on this? You need to balance the -3 by the +3, right?
Yes, sir.
Okay, that's why it is X is equal to 3. In order to not to have that confusion, I am including before the equals to. Understood?
Yeah.
I
Okay,
can
sir.
tell you this way. I can tell you this way because the chlorine is -3. So I'll put after the equals to 3. But then you should have the logic that it is balancing. So it should be the opposite charge +3. You should know that. That means I'll be simply putting is equal to 0. Then what is the charge that is balancing this? I mean, what is the charge on this X that's balancing this chlorine? So that will be -3. That will be kind of logic. So I don't want you to put into stress. So I'm explaining this way. Understood?
Yes, sir. Understood.
Now see here, what is the name given for this? So we should be selecting the ligands and their alphabetical orders. So what are the ligands do we have? One is the amine group is there. That amine group is a triamine. So should I consider T or A for alphabetical order?
A for alphabetical order, sir.
Yeah, A will be considered. Next, what we have? We have a water. So that's a tri-aqua. So should I consider A or T?
Aqua.
Yeah,
I
A.
mean, A.
Seeing this both are A, so I'll be just writing the same order. So I'll be writing it as tri-amine, tri-aqua, and this is a chromium. So chromium. And what is the charge?
3.
3. So I'll be putting the in brackets the 3 charge, and I'll be writing the chloride. Understood? So this is the name.
Yes, sir.
So do you hear any songs in the background?
No, sir.
No, sir.
Okay, fine. So next, tell me what would be the answer for this. First of all, calculate and tell me what is the oxidation number for this. Already it's given 4. Tell me how it is. Tell me how it is 4. So tell me what is the charge on the amine NH3?
Neutral, so 0.
0. What about this?
I guess -1.
Yes. What about this? -1. What about this? -1. What about this? -1. So I should add now X plus 0 plus -1 plus -1 plus minus 1, which I should equal to plus 1. Or I can also take this in. Let's not confuse you. Let me take here only. So this is also minus 1 is equal to 0. Understood? So now see here, x total minus 4 is equal to 0, x is equal to 4. Or I can, if I don't want to take this chlorine on my left side, then I'll be taking on the right side as a plus 1. So now these minus 3 all will go to the other side as a plus 3. So that also becomes like 4. But it will be confusing you. So do instead just simply write all the charges on the left side itself. Understood? And take on the right side as 0. That's better. Is this clear?
Yes, sir.
Yes.
Yes.
Okay, fine. So now see how do we give the naming. So first prefix indicating the number of ligands, how many ligands are there. So try three amine groups are there. So I'll be putting the 3 amine. So tell me what is the alphabetical order for this? We have a amine, we have a bromine, we have a chloro, we have a nitro. So the alphabetical order will be amine,
Amine,
Am I?
then
bromo,
followed by bromo,
then
followed
chloro,
by chloro, followed by
then nitro.
nitro. Yes. And the central metal atom is the platinum, and the oxidation state is 4, and the counter ion is chlorine. So what will be the number naming? So see which one option is following it.
Option A, sir.
Yeah,
Yes.
the option is option A. So next one. So for coordination complexes, we don't indicate the number of cations and anions in the IUPAC naming. Okay. So suppose if you see here, we never indicated any cationic or anionic there. Okay. And remember, sometimes the prefixes should be given as 2 bis, 3 bis, 4 tetrakis, pentakis, hexakis, heptakis. So why? So suppose you see here E and twice. So that's given as bis ethylene diamine. So Me2NH, that's a dimethylamine. NH2Me, that's a, if I write, see, dimethylamine, if you think and if you write it, that will be different. Where 2 methyl groups are attached to 1 amine group. In order to prevent that, within the brackets 2 is there, then I will be writing it as bis. Now this entire name is methylamine. So bismethylamine. I should not mention it like dimethylamine. If I mention that would be indicating like this. So 2 Me groups which are attached to 1 NH2 group. So that's what the diethylamine. But it's not like that. Understood? So where we'll be using the bis. So within the brackets, you should use this. If there are 2 or 3 or present like that, you should use the bis. Okay, fine. I'll be giving you a small work. So just find out the names of these compounds and let me know. Send it. So this is like a small work. So one is the platinum NS3 twice chlorine NO2. So tell me what are these names? Not only that, also tell me this. Including their oxidation number, you should calculate and let me know. Understood? So also find out their oxidation number and tell me what is their IUPAC name. Obviously, you need to find out the oxidation name number in order to write these IUPAC namings. Please don't Google it. You show clear solution how you have found the oxidation number as well. Otherwise, you can simply write it from the Google. So I want you to calculate and show me that calculation as well. Like how I did here. So this calculation I want. Is that clear?
Yes, sir.
Okay, guys, then we'll stop here. I think you are having at 5:30 the physics class. Any doubts? In 5-6
No,
classes,
sir.
we'll complete this chapter.
Sir, when anion is given first, how do we name it?
What?
Sir, when anion is given first, how do we name it?
When?
Anion is given first instead of cation. Like the potassium one.
No. Those will not be coming as the central metal atoms, right? See, potassium is not a metal, right?
Yes, that's it. Yes.
It will not come now. You will not be taking that as. All what in the first slide, if you see what is the name, always use the cation as the first when you have both the positive and negative. Do you remember the first slide that we started?